Myself Padmaja, Associate Professor, Department of CSE, Institute of Aeronautical Engineering, Hyderabad. Today we are going to discuss about preprocessor directives in C language. Now, what do you mean by a preprocessor? Preprocessor is a software which executes your code and then it forms the expanded source code before compilation. So, before C program is compiled by the compiler, the source code is processed by the software called preprocessor, and this particular process is called preprocessing. Every preprocessor directive starts with a hash symbol in your program. So, those hash symbols or those directives are replaced by the code. So, for example, hash define is there. So, hash define directive is used to define a symbolic constant. So, wherever in your program that symbolic constant appears, that has to be replaced by its correct value or exact value. Next is called, we are including the header files in our program. Hash include is also a preprocessor directive. So, the source code of those header files must be included by the preprocessor. So, before compilation, you will get the expanded source code for your program. Now, memory allocation process, if you will talk about, then it is like this. Normally, in your program, you may have some static variables, you may have some local variables, you may have some global variables. All these variables gets their memory in the permanent storage area, whereas only the local variables. For example, you have different types of memory, you have different types of variables, but global variables, static variables, and your program instructions, normally they get their memory allocated from the permanent storage areas, whereas the local variables are there, which are stored in a memory area called the stack memory. Now, if you talk about the memory division, you can see here the global variables, your program instructions, static variables, these are stored in permanent storage area, whereas the local variables are given memory space from the stack area. So, in between, there is a particular region that is called heap area. Now, this region is used for normally dynamic memory allocation during the execution of the program. Now, so let us discuss about your preprocessor directives. So, in C language, the preprocessor directives are of different types. Either it can be macros. So, the macros are defined using the hash define statement. So, normally the macro defines the constant values using hash define directive and can be any of the basic data types. Then, your header file, the second category of preprocessor directive is called the header file inclusion. Hash include directive is popularly used to include the header files. Then the third one is called the conditional compilation. Conditional compilation, for that there are certain preprocessor directives called hash ifdef, hash endif, then hash if, hash else, and hash ifndef. So there are certain part of the commands are included based on the conditions. Those are called compiled based on the condition. Those are called conditional compilation directives. And the last category is called the other directives, which is called miscellaneous directives also. Now, under miscellaneous directive, you have hash pragma is there, hash undef is there. There are certain your directives are there. So, basically, broadly, the preprocessor directives are categorized into this 4 categories: macros, header file inclusion, then conditional compilation, and miscellaneous directives or other directives. So, let us discuss about one by one. Now, first, let us discuss about the program process flow. So, whenever you are writing the source code, before compilation, it is expanded. Suppose you are writing sample.c as the source file. So, the expanded source code is produced by the preprocessor. It is a software which replaces all the hash directives and it will produce the expanded source code that is called sample.i. Then the compiler produces the assembly language code and that is sample.s, and then assembler produces the object code. So now the file becomes sample.obj, and then the linker will link with the executable code with the other files, and loader will load it and ready for the CPU ready. It will make it ready for the CPU execution. So linker and loader are the last two softwares. So it will take the sample.exe file. So these are the different steps for program flow execution. Now, let us discuss about the different types of preprocessor directives. So, in this example, all the statements which is started with hash directive is called a preprocessor directive. So, hash include stdio.h. This is called a header file inclusion directive. Then next, hash define height is 100 or number is 3.14, letter is A or letter sequence or backslash character. These are all macros. These are all macros that is defined using hash define directive. Now, these macros are replaced with its values before compilation. So, if you want to print the height, number, letter and all, these are treated to be symbolic constant for those appropriate values. Whenever I write height, actually 100 will be replaced. Whenever I write number, then the number is 3.14 is replaced. So these are actually replaced by their values before compilation itself. So this is the first example. Second one is called the conditional compilation directive. So first category is called hash defined directive, which are the macros also. Now, in conditional compilation directives, ifndef is a directory name which checks whether a particular macro is defined or not. So, if it is defined, then the if clause statements are included in the source file. So, if that your macro is not defined, then the else clause statements are included in the source file for compilation and execution. So, it is based on some condition. For example, you have defined a macro called hash defined RAM is 100. So, that means wherever RAM will appear, then it will be replaced by 100 that you know. But using your hash ifndef, how to use it. So, in your main function, we have written hash ifndef RAM. That means if the macro name is already defined in your program, then it will execute this printf statement. If your RAM name, this macro name is not defined by this statement, then it will directly go to the else clause. So, in this case, RAM is defined in your preprocessor in your header file. In your header file section. So, RAM is there already. So, it will print this statement that RAM is defined. So, this line will be added in the C file. Otherwise, it will come to the else clause. So, whenever you write hash ifndef, then automatically you have to write down the endif part. So, hash endif. Every hash ifndef should be closed with hash endif. Now, the next category of conditional compilations are ifndef and endif directives. Now, ifndef will exactly works as the reverse of ifdef. That means if that is not defined, then what you have to do? If it is defined, then it will go to the else part. So, if a particular macro is not defined, then the if clause statements are included, then otherwise the else clause statements are included for compilation. Now, you can see over the similar example, hash defined RAM is 100. So, we have defined one macro. RAM is there already. Now, we are checking in the main function ifndef Sita. That means if Sita is not defined, then this printf will be executed. So, Sita is not defined, so this printf has executed in the output. You can see over here. And then we are again define Sita with 300. Yes, you can define. Hash defined directives can be used anywhere in the program, but it is just a convention that it is always better to write at the beginning. But you can write anywhere in the program also. So, the else part statement is not included in for your compilation, and then you have to write endif. So, for ifdef or for ifndef, you have to write endif. So, both are opposite to each other. Similarly, in your program, there are certain other conditional compilation directives like hash if, hash else, hash endif directives. You can write it out. For example, we have defined a macro with a is equal to 100. So, okay. So, a is a macro we have defined over here. Now, we are checking through if clause hash if a is equal to 100. That means the value of the macro, how much you have defined, that is 100. Is it same as this 100? That means LHS is equal to RHS we are checking. So, if it is same, then this print statement will be printed. Otherwise, if the values are not matching, then it will come to the else part and this statement will be included for compilation. So, this way, if else is used. Now, whenever you are using a if clause directive or for conditional compilation, if you want to undef, if you have defined a macro, but if you do not want, so you can undefine a macro using hash undef directive also. For example, hash defined height is 100. That means height is 100. So this is a simple macro you have defined. So wherever height will appear, that should be replaced by 100. But for example, so I have first the print statement. I am printing the value of height, so 100 is printed. Then immediately I am doing undefining the height. So that means the macro will be no more recognized. It is undefined now using hash undef. And if you want to define it again with some new value, again you have to write hash define height 600. That means second time it is again redefined with height value 600. So for every hash define, you can write one hash undef if you need. Then there is a miscellaneous directive like undefined. We have pragma directive. Now certain functions, if you want to execute during the startup of your system or during the shutdown of your system, then for example, I want to play some songs during the startup, or I want to give some message during my starting or booting time of my system or during my shutdown of my system, then those files can or functions I can write and include in my pragma directive. Let us see how to do it. Suppose function 1 and function 2, two functions are there. These are the prototype which takes nothing, returns nothing. Now then I am using hash pragma startup and exit. So during startup I want function 1 should be executed. During exit my function 2 should be executed. So in my main function, so whenever you are writing pragma startup, so during your startup function 1 will be automatically executed, and during my exit the function 2 will be executed. This is the usage of pragma directive. Now let us talk about the summary of the preprocessor directive. So we have learned about the hash define directive, so which will define a macro. Then hash include directive we have discussed, where you can include a header file or any other file, program file. Then hash undef is to undefine a macro. Then hash ifdef and hash if endef is whenever a macro is defined, this will be true, otherwise it will be false. Similarly, in the ifdef, if you want to select some clause, then you can write hash if, hash else, and hash elif, hash endif. All those you can use it for conditional compilation. Similarly, hash error is there. Whenever you want to include this, then a particular error message will be displayed on the standard error device. Then your hash pragma can be used, or which is used for issuing some special commands to the compiler using a standardized method concept. Now, apart from how to define a macro, let us discuss about what are the predefined macros available in C language. Let us discuss few of the predefined macros available in C. So, printf, suppose underscore your underscore file, date, time, line, stdc. These are the certain predefined macros are available. So, if you want to check that what is that means what value contains in that macros, then you can simply print it and check. If I want to check the file, if I want to check the date, time, line, your ASCII, so your ANSI and so on, then I can just simply print it. So date will print my today's date, your current student's date, then time, then line, how many lines are there, and then ANSI, all those values you can check it. Then apart from the preprocessor directives, in your C language, there are certain preprocessor operators are available. So let us understand about those operators. So the first operator is called the macro continuation operator, that is called the backslash. Macro continuation operation. So whenever whenever you are defining a macro which will extend to more than one line, then you can use this continuation operator. For example, has defined message for a comma b. That means I'm using a parameterized macro here. So parameter macro I'm writing, and this macro is extending for more than one line. So I can use this operator called slash. This is called the macro continuation operator, which means that this macro is still there. And this is the printf statement we have used in this second line. Then the next operator is called your string is operator. Now this operator, the string is or number sign operator, when used with the macro definition, it converts a macro parameter into a string constant. So how to do it? Let us check it. Now, for example, you have defined a macro and we have written that your string is operator we want to use. So here hash is the string is operator. So hash A and hash B we have written. So for this macro, this is a parameterized macro, two parameters you have to pass. Suppose I am passing Ram and Sham. So hash A and hash B is replaced by Ram and Sham. So it will print the statement Ram and Sham, we love you. So the replacement for string is nothing but the value of the parameter will be taken. Then the next operator is called token pasting operator, which is nothing but double hash. So the token pasting operator with a macro definition combines two arguments. So it permits two separate tokens with the macro definition to be joined into a single token. So how to do it? Let us see. So define has defined token paster, and so you have defined a macro. So where you have written that. So whenever you will find a token, then you have to paste it. So for example, token 34 is equal to 40. So we are using token paster 34. So with your we are token paster, we are passing one argument called 34. So that will be pasted along with the token number. So token 34 is equal to 40 is the output. Now there is one more operator that is called defined operator is there. This operator is used in constant expressions to determine if the identifier is used is defined using hash defined or not. So you can write if not defined the message, then define it. Okay. So not defined. So defined is nothing but it is an operator. So let us check it. Suppose you are printing that message. Message is nothing. You are passing some message. Then that if it is not defined, then you will get. Then it will define that message. So you wish. Then the macros are of two types. One is called simple macros. One is called parameterized macros. So you can write macros in two ways. Simple macro. And the second category is called parameterized macro or parameter macros. Macros with parameter, which takes some arguments or parameters. So let us understand one example. Suppose we are defining a macro as defined max of x comma y. So x and y are called the parameters here or arguments. Now what you are writing for this macro, what you are defining, if x is greater than y, then conditional operator we have used. If it is true, if x is greater than y, if it is true, then take the value of x for maximum. Otherwise, if it is false, then take the value of y as maximum. Now, so suppose we are giving two numbers to this max macro. So max of your 10, 20 you are giving. What is the macro we have written there? We have written x greater than y. Then take x, otherwise take y. So 10 is greater than 20. It is false. So then it will take the final value, that is 10 or 20. So the final value it will take it as 20. So the maximum number between 10 and 20 is 20. So this way parameterized macros are used. Thank you so much. In this video, we have learned about the preprocessor directive, different types of preprocessor directives with examples. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.